Hey guys, what's going on? It's Danny, and today we're going to be talking about LeetCode number 50, POW x to the n. In this video, we're just going to be talking about the general solution. We're going to be walking through it and talking about it with a recursive focus. If you were watching my last video, you know that recursion is basically the idea of a method that will call itself, so it'll be running methods over and over within itself, basically calculating smaller subproblems. Very similar to dynamic programming. A lot of dynamic programming solutions are similar to recursive solutions to equations, and understanding when to use both, when things make things simpler, when things make things less complex, is very important as a software developer and something worth learning about. So whether you're a new student just out of CSA or a student currently in CSA wanting to learn about recursion, I hope you gain something from this. And if you're a more experienced developer, someone who's coded a lot more than me, I hope that you maybe find this funny, or maybe find interest in the way someone who's slightly newer to programming than you, I'm only 17, understands, and how I understand code. So to start off, we're going to be talking about our problem solving process. We talked about this last video, and there's two-ish main steps to solving a recursive problem. First thing you got to think about is, what is the problem and what is the recursive call I'll be doing? What is this subproblem that I can keep using earlier solutions for? And to do this, I always like to write out the problem. So the problem is calculating exponents. Exponents is just x to the power of any number, just means x times itself that many times. So if it's x to the power of 5, it's x times x times x times x times x 5 times. Just x times x 5 times. And that's how you calculate that. But in code, it's a little bit trickier. The way I think about doing it is step by step. So this is each step written right here. This is each individual step. And we know that in order to find the value of this, we can just do x times the value of this, and then x times the value of this, then x times the value of this, and that's where it breaks off right here. This is the, base sequence in where you can kind of just stop. So yeah, so we're going to start off with our recursive call. We're going to call myPow on x, comma, n-1. And the reason we're doing n-1 is because we're going to actually multiply this by x. We're taking out that x minus that 1 from the n, and we're just multiplying by it. We're just doing the exponent. We're multiplying by 1 less, and that's how it works. And we're going to return this. And sick, that's our solution to the problem, right? No, it's not the solution to the problem, but it's a great step on that track, because this loop would run infinitely. We need to think, when should this loop be stopping? And this loop should be stopping when it gets to an exponent value that's, not something that needs to be calculated anymore. So for example, if n equaled 0, we would return 1, because any to the power of 0 is 1. Another good case to think about is if n equals 1, we're just returning x, because anything to the power of 1 is just the number itself. In the final case that a lot of people in my computer science club, when we did this problem today, missed, is the negative exponent. This is slightly tricky because you don't actually have to code a different solution to this with division and all that and whatnot. In fact, you can actually just use recursion for this, and that would be if n is less than 0. So if n is negative, we're just going to do myPow of return myPow of, or x times myPow of x, comma, math dot absolute value. No, we're not going to use this up front. We're going to do math times x, comma, absolute value of n, and this will make it positive. But because we know it's negative, we're going to divide by 1, because negative exponents is just, you can flip it underneath the denominator. So you put a 1 over the top, move the exponent to the bottom, and then you make the exponent positive. So example, if it was x to the negative 2, that just becomes 1 over x squared, and that's just the algebra and math behind it, something that you should probably know if you're getting into computer science. But yeah, so if we're looking at elements that are less than 0, we're going to return 1 divided by that of the absolute value of it. So this is, we're just going to put the normal power of it below it, and 1 divided by that will give us the answer to this. And that's what, this is the first call, so that's what it returned first. Now, once these first 3 cases are met, this seems good. We're probably thinking we're all going to submit. Oh, we're missing a That's not gonna compile. Yeah, we need a you need your semicolons, Java. But something didn't compile. We have n to the 200,000. This is an extremely large number and something we didn't account for. And you may be thinking, oh, this could be because of the integer limit or whatever. But in reality, it's actually going to be because of the fact that it's a it's just a very large number, and it's too many calls for our program. Our program will be running 200,000 times, 200,000 calls, which is quite a lot for any computer, and not something that's very optimal and you want to be doing. So if you have a situation like this, you want to think, hey, how can I shrink down this solution? And so it's such a big number, but how can I take a shortcut? So if I was doing this by hand, x to the power of 100,000, how would I do this? The first thing I'm thinking is, how can we simplify the exponent to make it smaller? And that's by factoring it out. We can actually do x to the power of 2 to the power of 50, whatever it is, with some number. And that tells us a whole lot, because now we only need to do this number 500 times. We did one extra operation to get this, and now all we have to do is do half of the original things. And that's just amazing for the complexity, and will help us out quite a lot. So if n mod 2 equals 0, we're going to return x times, or my pal of x times x. So this is that factoring out that x squared and putting it right in there. It's right there right now. The math is done right there, and it's easy. And now we can do n divided by 2. Okay. Now you're probably thinking, this is a little bit confusing, but let's double check if it works. So the first one works, and okay, so we have a Stack Overflow error on this line up here because it's out of bounds. And the reason for that is because you can't take the math, you can't use absolute value on something that's integer limit. So instead, we're going to negate this by subtracting what? X times. We're just going to do it right in there, right away. Oh, and we should also probably do that absolute value down here too. And that absolute value will make sure that no matter what, it's going to be a positive value at the end. So yeah, right here it's a -3, which is not good. Math.abs of n. Oh, I keep running the code. What? Hold up. Something's wrong with the, I think, syntax somewhere. Oh, it's up here. It's because we have an x times x here, but that should only be down here. We're not going to multiply x by x here. We're going to do it on the outside of this and incorporate it back in. So what this line is this line is saying if it's negative, we're going to do 1 over this and then run this line down here anyway. So this is just this line copied and pasted up here. And the reason why I have the math.absolute value here is to make sure that we're converting it properly to a positive number instead of just multiplying by a -1 and subtracting 1 to find out what 1 less than it is. And so, hold up, if we'll see. Yeah, so this gets 100% B, and this is one of the, I guess I don't want to say rare cases, but this is one of the cases where you're going to be able to find a recursive solution that's optimal to the problem. And yeah, so hopefully this makes sense, but to recap it, we're going to go through the entire solving process again to see how I come up with the solution and how you can come up with a solution to your own problems in class, in whatever, just in life, in whatever programming you're doing. First, we read the problem and we understood it. We wrote out the x times x. Writing down these problems is so big. Being able to visualize this stuff will help you create your own algorithms and apply the ones that you already know. So x times x times x, we thought about how can we split this up into some problems. While there's some approaches where you can do divide and conquer, in this one we chose to do just split it up right at the x times the value of this, and then the value of this times this, and whatnot, and that's what this line is. And then we thought about base cases. We thought if we're going to keep going down and down and down in the power of the exponent, we need to stop at some point. And so if it's 0, we're just going to return 1, and if it's 1, we're just going to return x, because ending to the power of 0 is 1, and ending to the power of 1 is just the whatever number you had in the first place. And then the final extraneous check we did was to see if the number's negative. If the number's negative, we need to actually flip it, which is 1 divided by that, and then we just run this same line down here again, to calculate, just to start the recursive call right there to save complexity. Excuse me. And then for our final piece that we add, this is the nmod 2. This was the part that I think is trickier to get the hang of, and the reason we were able to find this is because we broke down the problem even further, and we saw spaces to shrink down large numbers. Places where you can easily just cut it in half, divide by 2, use the square root of it. Any of that is great, and this problem is a great example of something like that. So that's just about concludes our video for today. If you haven't liked the video, I guess, and if you're, from the beginning of the video, if you're one of those CSA kids, someone who's new to programming, maybe you go to my school, maybe you're just watching my videos, feel free to comment and leave any questions you have, any topics you want me to cover, any CSA thing that's tripping you up. I'd love to cover that. But otherwise, if you're a more experienced developer, I'd love to hear your feedback on the code I've been writing and any tips you have. But aside from that, thank you for watching my video, and I'll see you around.